Day 68, page 272, rotational kinematics, problem 33. So here are some basic principles about gears or wheels that are touching each other. Number one, and we're going to take a lot of shortcuts here because as long as you're using the same units, you can play with the units you got, use the units you have. First principle, as one wheel rotates clockwise, and maybe you've done, the best place I've ever seen this is with child's gear games. I mean, little kids like 2-year-olds and 3-year-olds, sometimes they have these gear boxes where you put a gear on and this gear turns clockwise, and you have another gear here, it always goes the opposite way. So every time you have two gears or two wheels touching, each wheel turns opposite the other one. You can think about that or go back to your past and remember that that's the case. So this wheel and this wheel and this wheel, every other wheel turns in the same direction. So the final wheel, as long as it's an odd number, will turn in the same direction as the original wheel. Also, just some general ideas. The number of teeth is proportional to the radius of the wheel. So a wheel with 80 teeth, I didn't draw the teeth, has 4 times the radius. And you can even think about it already, rotationally. For every one rotation this big wheel gives, this direction, this wheel has to rotate 4 times. So if it has 4 times the radius, it will turn 1/4 as fast. Or in other words, if it has 1/4 the radius, it will turn 4 times faster to keep up with the same tangential speed at that point of contact, which is one of the other principles down here at the bottom. The tangential speeds are all equal for every wheel. The point of contact has the same tangential speed. So with that in mind, it's very easy. I mean, if you look at the relationship between velocity, tangential velocity, this is V tangential, is equal to R omega, the rotational speed. So V1 equals V2 equals V3 equals V4 equals V5 equals V6 equals V7, as long as all of them are touching each other. So that means that R sub 1, omega sub 1 equals R sub 2, omega sub 2, yada, yada, yada. All we care about, though, is the first one and the last one, but we don't need to worry about all the ones in between. And once again, if you just stick with RPMs, you don't need to do radians per second. The answer will come out in RPMs. So bottom line is that fifth wheel is spinning almost 1/4, not quite 1/4 as fast, because it's almost got the 4 times bigger radius. But bottom line is just take 20, the radius of the first wheel, number of teeth, times the speed of the first wheel equals the radius of the last wheel times the rotational speed of the last wheel. And there you go. It's about almost 1/4, not quite 1/4. 400 RPMs for the last wheel, spinning in the same direction because it's an odd number from the original wheel.